every household is a big market, right? So I need to scale a lot further. And I also have a product which is so easy to use that anybody could use it. So I think this is another 2 or 3 years, maybe, I'd guess. From a price perspective, we're going to get there. The issue is more solving the issues in the application, making it easy to use, understanding the application, and also coming up with use cases that you want to do. For example, let's say you live in a neighborhood with lots of Wi-Fi signals, like many of us do. So I get at least 20 Wi-Fi signals here. So you're going to shield your house, and you're going to get rid of those Wi-Fi signals, reflect yours, and you're going to have a way better connection.
Hey everyone, welcome to It's a Material World. We're the show that uncovers why material science will change the world. Consider subscribing and hitting the like button down below. It would really help us out. And also, we have a free MSE Company Database categorized by industry sector, location, as well as internship and full-time titles. So if you're interested in that, you can find the link in the description below. And now, let's get on to the episode.
Hey everyone, we are excited to welcome today's guest, Dr. Robert Brüll, the CEO and co-founder of FibreCoat, whose mission is to make high-performance materials affordable for everyone. Robert and FibreCoat have earned multiple prizes for their aluminum-coated composite fibers, including most recently the JEC-World Award, one of the most renowned awards in the composite industry. Just like us, they believe in material science that has the potential to sustainably improve our environment, society, and our lives. So we're looking forward to diving into the story and the technology today. Thanks so much for joining us, Robert.
Thank you for having me.
Awesome. So it seems like a motivating factor to start FibreCoat had to do with the fact that kind of the industry was slower than you wanted it to be to pick up on innovative technologies. So you basically were like Thanos and just said, fine, I'll do it myself. And so we were just wondering if you could discuss how complex composite production used to be in the past, and then how that differs from like your materials and processes today.
Sure. So basically a composite is, as the name says, a composite of different things, right? So you have a fiber, you have a polymer or some kind of matrix system, and then an interface between those two. And each one of those parts is to be produced on its own. So you spin fibers, you make a textile out of it, you make a polymer or something, you combine them. So it's a very long process with many steps. It is obviously costly and complex and hard to design with and so on. So what we tried at the university in 2014, when we started the whole FibreCoat thing, was can we combine all of that into one single step? So basically, spin the fiber, bring the matrix system onto the fiber with an interface in between, and have the composite finished in one step, so that this can be used to be produced into fabric or some kind of textile that then can be pressed into a final part. So in comparison to what is out there, we have a single step composite production, which yields a better quality and is more efficient and price-wise cheaper.
So going from this multi-step, very complicated, very costly, how much time savings could you say generally it is to go from all these steps to one single step like you're doing?
From our estimates, we save around 50 to 80% of the overall time. Now it's kind of hard to say the exact time because we save some steps in between, right? So these steps can be very short, they can be very long, because composites come in all different shapes, forms, and sizes, right? So you can think about a part for an aircraft, which is very complex, and we save many steps, or you take something which is injection molded, which is also composite, which was only one step before too, so there's not a big difference. So but from 50 to 80% overall time and cost savings is our estimate. Yeah.
Awesome. That's super impressive. So what did that like discovery of this process or the development of that process look like? And because, you know, there's just the traditional way of doing things, and then to save time by 50 to 80%, that's a drastic innovation. Can you talk through that?
Sure. So the big difference is that we combine the steps into one. Basically, when the fibers are spun, we coat them straight away with the matrix system. So with the part that usually forms up the second part of the composite. So the fibers give the strength and the matrix give form and secure it from environment, basically. And by coating it straight while they're being spun, we don't have to add anything else. But the fiber itself becomes a composite, which then can process into a bigger composite, so gluing them together, basically, and saving many steps along the way. Plus, our system runs at between 1,000 and 1,500 meters per minute. So it's way more efficient than standard composite, like where we bring the matrix together, it's something like 5 to 10 meters per minute usually.
So now that you kind of talked about the system, your company creates aluminum coated fibers, which are the longest reinforced composites in the entire world, as they're literally multi-filament yarns. Can you kind of dive into the material's unique properties and what it took to make this so affordable for everyone?
Right. So when we started, we wanted to make a polymer coated fiber to use it for lightweight construction. Then we founded the company and COVID hit. So we didn't get anything like polymers or extrusion equipment. So nothing worked anymore. So we had to pivot and we just said, okay, we work from a molten state. So we use a melt that we coat onto the fibers. Metal is easier to melt than polymer, even though it's hotter, but it's from a technical standpoint easier. Let's try that. And it turned out fairly easy. Don't tell my COO because it wasn't easy at all from his point of view. But it turned out pretty good. So basically, because we were able to coat at high speeds with the metal, we achieve the best of two worlds, right? So we had the core fiber with high strength and a metal sheath of aluminum that is highly conductive. So we're able to produce a highly conductive yarn with high strength in a very efficient way, which is like a deal breaker for the industry.
Yeah, I'm not sure if you're allowed to talk about this, but basically I know a few things about like speed. So like you said, like before it was 5 to 10 meters and now you're like multiplying by 10x, 20x, like insane amounts. How can you ensure the same quality at such faster speeds with this revolutionary technique?
It's kind of a secret sauce in there. That's right. But what I can say is because we work from a molten state and the speed is actually beneficial for us because it gives us a very uniform coating when the fibers pass our system. And this gives the good properties. So basically the core fiber doesn't change at all. And the coating is very homogeneous along the length of the fiber. So basically that's how we assure the quality. We also have some quality checks in place. So we have to do like, obviously, when we send out fibers, we have to check the quality before we send to our customers. But mainly it's having a very stable system and high speed actually helps us in that regard.
So this is more related to like the life cycle of the product, but at Georgia Tech, we attended like an info session with Novellus, which is like an aluminum like recycling company. And so I know that aluminum is super recyclable, I guess like 99% plus. I was just wondering if how that factors into like your sustainability side and recyclability for your fibers.
Yeah, that's a great question. And actually, it's always the second question when we talk to any customer, like how is sustainability, how is recyclability? It's a super big thing right now. In our combination, we chose to coat basalt fibers with aluminum. And what this gives us is a composite that is in the same structure and the same combination as you would find aluminum in nature. So basically, if you mine raw aluminum, it's always a mix of aluminum basalt. So we can use the same systems that you would use to refine that aluminum for our fibers. So we can just throw it up in there and recycle all of it in the same way. Wow. Now, if you had polymers, things change. I'm honest. So we have the same issues with the plastic reinforcement, fiber reinforced plastic as everybody else. But the material itself is used, as long as you use it as a textile, very easy to recycle. And we tried, so this was very important. So during our development, we had this in our focus all the time because we can't just make more waste for the world. We need something that is actually can be reused.
So did that end up being like a blessing in disguise when the pandemic hit, that you just kind of pivoted to the path of aluminum versus polymers? Kind
of, yeah. Polymer coated fibers are still in development, and we also have some sustainability aspects there. So it's going to be, hopefully we hit markets in the beginning of next year. But overall, we were very lucky to have that our system is so flexible that we could just pivot and reach industrial scale. So we went from 0 to 1 ton per month production a year, which for material sciences is very quick.
That's very impressive. So before we get into more of like the material science of it all, I was just wondering, what is your like long-term vision for FibreCoat?
Okay, so as I kind of mentioned, we have different types of systems. Because we work from a molten state, we can use anything that melts, basically. There are some limitations, but overall, we can use different metals, different polymers, even ceramics. So anything that has the right viscosity can be coated with our system. And also any fiber that is produced in the melt spinning process. So that's basically the type of process that we need to piggyback on. So our goal is to come with more and more material combinations that solve more and more issues out there, to build a company that is like one of the big material suppliers, but with a focus on composites. Because so far, most of these material suppliers, they have a focus on thing, but the combination is actually the next step innovation, we think.
That's awesome. I think that leads like right to kind of the first application that we want to talk about. So first of all, like your fibers, you're aiming to make them like as affordable as possible and damage resistant for instance, integrated electromagnetic interference shielding. That was a tongue twister a little bit. And also like weight reduction in electric vehicles. So let's take it maybe one step at a time. Can you talk us through how the structure and the composition of your fibers contributes to its lightweight properties?
Yeah, because we don't change or lose any properties of the core fiber, we retain all the strength of the fiber, so we can use it as a reinforcing material. So in comparison to metal sheets or bulk materials, the fibers have a very high strength in their length, basically, and you can leverage this in lightweight design. So think of it like spaghetti in a tomato sauce. If the spaghettis are stiff, right, they're very strong, so you can't break them or pushing on it. You have to bend. So basically, the matrix system is the thing that makes them impossible to bend, and then their stiffness takes up all the force. So you can design much more in the load-bearing directions of your application. So you can design thinner with less weight because you can use more of the material properties, and the end gives you the option to have a lightweight design. Now, the drawback is it's more complex. So a bulk metal is always easier to work with than a composite, because the composite you always have to like mix and match those properties to the application that you have. But in the end, you reap the benefits of less weight and then less fuel consumption, less CO2 emissions, and so on.
One question I had was that you're talking about how basically it's a lot more maneuverable than like aluminum or other pieces, especially for electric vehicles. I know that it's probably in the news, but Tesla has the gigacast that's like reducing all these unique parts down into it. How does that's kind of the way of the future, right? Is reducing manufacturing to simpler parts so that it's faster to manufacture. How does your product kind of fit into where like it meets? Like, could it be used as like the connection between all these distinct parts that are now getting simplified and simplified?
I think simplification is a thing that happens. It's true. I mean, I agree. But in the end, at the same time, you also want to stay to improve on what you're doing. So we can't just go back to all steel heavy frames because it's the simplest way of doing it. You need to use new technologies and need to integrate functions. And for an example, if you think about cover for electronics, you always have different things that they have to do. So one is they have to keep the electronics safe and dry and safe, basically. Then they have to keep the electronics cool in there, right? So basically having air pass through them. At the same time, they need to shield electromagnetics. So if you do it all in an aluminum frame, you need to have complex cooling systems in there, and it gets more and more complex to achieve those goals. Now, if you had a textile, basically welding together the aluminum part of the textile with the aluminum part of the housing, so basically you can cool, shield at the same time, and you lighter than before. So this is a way to integrate those functions into the same design. And I think that every type of material out there has its unique properties that you need to achieve those goals. You can't do a car all by aluminum or just with plastics. So you always need the combination to some degree.
Cool. And so you mentioned the shielding aspect. Can you explain the importance of shielding, first of all, and then how the structure property relationships of that fiber allow it to have these shielding properties?
So shielding overall is becoming more and more important. I mean, I guess you notice that we have 5G in the world now. We have Internet of Things where your phone talks to your fridge and your fridge talks to your car, and I don't know whoever the car talks to. So all of these things get connected, right? And with more and more of these devices out there, and we have more and more radiation, and that radiation in turn leads to interferences in sensitive devices. So for example, a self-driving car or medical equipment, they might have malfunctions because of interference. Now, that's an issue because you don't want your car to crash or your medical equipment to fail, right? So you need to shield those sensitive electronics in order for them to work properly. And this is becoming more and more important because we have more and more radiation and more. So 5G, for example, also has a higher intensity than like the GSM network that we had before. So shielding becomes more and more important, and it's becoming a mass market issue, which needs to be solved in a bigger scale. So up to today, it's mainly aluminum foil or aluminum casings that we used, but they have the drawbacks of being heavy and not porous, so you can have air passing through. And our fibers solve that because our fibers offer the whole shielding effectiveness while being flexible, drapable. They can be integrated to composites. They can be used even as a clothing thing, basically. So because they're textile, we give them so much more flexibility. And this was possible before too, right? So metal fibers were out there for decades. It's not a new thing, but they were very expensive, so people didn't use them. So that's the key thing that we solve, basically, making them affordable.
And so, like the second part of the question, could you kind of go back and explain a little bit about how aluminum in this case is able to shield like your subject from the other 5G signals or other signals?
So the easiest way of explaining is a Faraday cage, which I guess you're aware. So you're familiar with. So we can create a Faraday cage around the part. Now, shielding is very frequency dependent, and it gets a bit technical because lower frequencies, they are harder to shield with our fibers. Higher frequencies are easier to shield, and then it's also a topic of how far away is the source and how long are the waves, so basically how tiny my holes can be. But overall, the key thing is a conductive material like aluminum, which is it's highly conductive. It's, I think, the second most conductive metal out there, offers me the conductivity that I need for shielding. So for electrons, basically the wave hitting the fibers and then flowing along the surface around the part, like a Faraday cage, and shielding the inner part. Or the other way around, right? When you have an antenna or something that is emitting radiation, you don't want to get out there. For example, in a car, you don't want the pedestrians to be exposed, or the people in the car, to high radiation from the components of the car. So you need to also shield the components internally too.
And so I know a little bit about shielding, and so the spacing of your matrix is very important for what type of signal you're trying to block. Is that a large benefit that now you have these fibers that you can control, or like how much simpler is it to use your solution versus trying to make something out of like cast aluminum or a sheet of aluminum?
Okay, honestly, it's always easier to make cast aluminum. It's just from a shielding perspective, it's super easy because you don't have to take care of anything, only the thickness. Mm-hmm. Now, with our material, we try to make it as easy as possible because we do help our customers in engineering so that they can use our fibers. But in the end, from a customer's perspective, because we give them the right textile, it's as easy as it was with cast aluminum, for example, because we have some benefits in our fibers, like we have multiple reflections. It being a textile, we can work with thickness, we can work with different orientations of our textiles, so having 2 or 3 layers to achieve very high shielding properties with less material than before at an affordable price. So that's always our goal. Up till now, we cannot compete with aluminum foils, but we will get there. So the economics are clear. Give us another 2 years and we're going to be able to compete with it.
Oh, okay. Wow. That's impressive. I was just like about to ask you. So you mentioned the affordability, right? So you said, is that right? 2 years? Like how far are we away from seeing like shielding fibers or whatever material in like all households around the world?
So it's an issue of scaling, basically. The technology is clear how it works. It's also stable. So we produced around 5 tons this month and starting the second line actually this month. So you're going to be about 10 tons production per month next month. But every household is a big market, right? So I need to scale a lot further. And I also have a product which is so easy to use that anybody could use it. So I think this is another 2 or 3 years, maybe, I'd guess. From a price perspective, we're going to get there. The issue is more solving the issues in the application, making it easy to use, understanding the application, and also coming up with use cases that you want to do. For example, let's say you live in a neighborhood with lots of Wi-Fi signals, like many of us do. So I get at least 20 Wi-Fi signals here. So you're going to shield your house, and you're going to get rid of those Wi-Fi signals, reflect yours, and you're going to have a way better connection because your Wi-Fi is reflected, right? At the same time, your phone won't work anymore. So you have to make your calls over Wi-Fi. So there's a lot of education and thinking needed to get this done. Also, trivial things, we're looking into shielded curtains, for example, because you still want to have windows in your house, right? You don't want to shield off the windows. So you're going to need curtains. So there are many details in the consumer sectors that we need to flesh out before we're going to get there. That's why we focus on government, hospitals, cars. That's way more technical and actually easier to work with than consumer.
You're basically answering my questions like before I asked them. So
sorry.
No, you're a great guest for it. I was just wondering, are there any other applications? So you mentioned like households, I guess, buildings in general, and vehicles. Are there any like smaller applications or any other applications for this technology?
Yeah, we have a lot of applications. So if I think about our conductive fibers, households or buildings in general is very big. Shielding is one thing. Also, what I wasn't aware up till before we started, I didn't know anything about EMP strikes. It's really a very big issue for shielding of hospitals and government buildings.
Can you explain that in more detail? What is an EMP strike?
An EMP is basically an electromagnetic pulse, which can be triggered to shut off all of the electronics around that pulse. It can be actually several hundreds of kilometers wide, depending how strong it is. And this sounds very sci-fi, but there's a market out there for people looking for affordable shielding for these big, like hospitals, for example. That's we weren't aware of this, for example, right? But there's shielding and there's also heating. So you can use our fibers also for heating. This is something we're looking into, like heated wallpapers, for example. Sensoring, you can use our fibers too. We have a lot of applications in the defense sector that leverage our connectivity. But also down the road, we want to go into smart textiles, electronics, and even design. So we had several questions for our fibers because you have this metal shininess. People like it. We can even color the metals. So maybe even design down the road is something we can look into. Good thing about design is nobody cares about the actual properties of the material. So it's actually a bit easier.
Yeah, because you're such an expert in this field, it's very interesting. You're saying all these benefits about we can shield hospitals, et cetera, from these attacks. But at the same time, one of the big things about the Internet of Things is the connectivity. So I guess there's going to be some point in the middle where we're going to meet. Could you maybe elaborate on what that might be or what that might look like?
Yeah, so the thing is, if you shield something completely, it's shielded, right? So the connectivity is gone. And there are ways of having pass-throughs for cables, basically. So you can have an internal antenna and an external antenna. That's how your Wi-Fi works too. So if you have Wi-Fi in your basement, it's only through that cable, right? So there are lots of techniques where honestly we don't do anything there to pass through signals through shielded areas, because the issue is if you have a pass-through, the bad stuff can also pass through, right? So it's basically a hole in your shield, which you don't want. So you need to work with, so for example, that they very long metal tubes where any signal dissipates before it goes through, where the cable can pass through. You have actually fabrics that allow cables to pass through. You then have devices that basically, so clean up anything that passes through a cable. There are many different ways of doing that. All of them not super cheap.
So now can you explain how the material development changes for different like applications? So you mentioned some potential applications down the road, like conductive yarn for smart textiles. How would that materials development change compared to fibers for spacecrafts?
Yeah, so in the end, it's from our perspective, it's going to be a coating in either way, but the properties that you need are very different. So for a smart textile, for example, first of all, you need some stretch, you need some washability, right? You need something that you can throw into your washing machine. It comes out in one piece. Right now, with basalt coated with aluminum, it'll come out in a lot of pieces. So you can't wash it basically. So we need to coat polymer fibers, which have more stretch, and then you would need to think about a coating on these fibers to make them processable and to be able to handle them. So what I said in the beginning, composite is always a fiber, a matrix, and an interface between those. And this interface is called sizing. So you need to develop a different sizing for a different application, because the sizing can glue things together, the sizing can make them separate easily, the sizing can make an adhesion between a polymer or give them an anti-static property. So you have many different things that the sizing does. And this has to be adapted to the application. So one is having the right combination. And if you say spacecraft, the big difference is you can use the very best solution for spacecraft because nobody cares about the price in the end.
Yeah.
So you can really use like platinum coating on a ceramic fiber, right? That's the best lightweight, highly conductive solution for an aircraft, for example. But I don't think you want to use this on your walls, right? Or your that's basically the trade-off you have to make. Yeah, exactly. So that's why we try to design for the industry. And obviously we're a startup, right? We have one product, the second coming up next week, the next year. We're not that quick, but our goal is to get there. We can come up with many different solutions.
So I guess maybe taking a step back, this has all been very fascinating, but when you first started FibreCoat, what challenges did you initially face being such a disruptive technology? And ultimately, how did you overcome these challenges to be where you are at today?
So one of the big challenges is the complexity of composites. So composites is always a combination of different things. And you have to understand all of the parts, right? You have to understand the fiber, you have to understand the metal or the polymer. And also to scale it, you also have to cover everything for scaling, right? I need to melt the metal, but also I need to spin fibers. So I need to have everything in there. So this was one of the big things that in a lab is fairly easy, but as soon as you get to industrial scale, it becomes complex and super expensive. So investing in a fiber spinning line of several hundred million euros and dollars is not a startup. So we didn't have that funding. So we did overcome this with partners, right? So we looked at our network, we found fiber spinning companies we can piggyback on and build our coating into the lines. So basically working with others was the solution to get a viable product. So this was one of the big issues. And the other one was the classic problem, I think, of all engineers out there is over-engineering. So up till now, we achieve, so we do have fibers with a full coat, right? But it's way easier to make a partial coat. So basically, the product is cheaper, easier to produce if I only have a 180 or 270 degree coating. And some of it stays naked, basically. Now, we kept trying hard to achieve this full coating and lots of time there until we said, okay, we'll just send out the bad stuff to the customer. Turns out nobody cares. So the properties don't change that much, except of maybe one or two applications. Nobody really cared about the full coating. And as an engineer, you want to have the best solution, the best product. But from a business and startup perspective, you just need to get customer feedback and just push it out, even if it's not ready in your mind. But it was ready. So
yeah, interesting. Okay, so now we're getting into like market research, but I kind of want to touch on it a little bit. When you just started the company, did you already have an idea of like what all applications this technology could make an impact in? And how did you end up discovering like potential new applications?
Yeah, we did have an idea and we were completely wrong. So we figured, because as I said, we started with the polymer coating on glass to make lightweight design. So we figured, hey, we can't get that done. We'll do it with aluminum and make fiber reinforced aluminum instead for lightweight design. But nobody really wanted that. So we reached out to companies and they said, yeah, we tried that. We don't know. It turned out that when we put a message out there and we won some of the prizes that you mentioned and got some feedback from other institutes and potential customers, they said, yeah, lightweight design is cool, but can you shield? And then we went down there. So I think we took 3 or 6 months investigating what does shielding mean? How does shielding work? Why is our material maybe good for it? And then we did some pilot project with the customers. So to be honest, we stumbled a bit in there, but my advice is just listen to what customers say and see if you're wrong, because we were wrong completely. Yeah.
And so I guess going back a step, you said that you approached other fiber coating manufacturers to have a partnership on. I guess as a startup, how did that partnership begin? Because you have a lot more value from them than potentially you, or how do you show them that it's worth working with a startup such as yourself?
I think we tried to create a win-win situation, and we were in a kind of a lucky state at that time that many fiber manufacturers had an overcapacity. So China was more or less flooding the market with glass fibers, and basalt was also flooded by Russia. And those companies, they had excess capacity, which they had to use because you can't can turn off an oven for glass or basalt manufacturing. They are 1,200 degrees, and if you turn them off, you have to rebuild the whole thing. So they had this overcapacity, and we came in there and said, hey, we pay you basically the price that you sell those fibers that you're not selling right now, if you allow us to put in our coating device and augment your product with the potential to have a lot more of this in the future. And to be fair, small companies, they jumped on that. The bigger ones, it's a longer time frame, right? You need to convince the corporate and I don't know who else. But this was the way. So we tried to create a win-win where they would be happy to have us. And we were obviously happy to have them because we had no other option.
And then, so going back to like the applications, like I'm just curious from the EMP strike, is that just something like you just happen to come across when talking to like potential customers or people in your network? Like moving forward, what is your plan to kind of expand and determine new applications or maybe dig deeper into existing applications?
So right now we decided to focus. So we're going to stay on short term is going to be construction and buildings. So because there the market is enormous and we can cover it with one product basically. So we have one shielding wallpaper. We can take a lot of that market. So it reduces our need for engineering. Midterm is going to be defense because there we have variations, but in the end, it's something which is a big ask right now. And then long term is automotive or mobility, so ships, cars, airplanes, because the time to market there is very long. In comparison to the others, but the potential is also enormous because these are actual mass markets. And if you get your foot in the door there, then you have a great relationship for several years. So you can really build the company on those. We do look at other applications and we send out fibers to partner startups and for testing, but we have to watch our resources. So we stay focused in these areas right now.
Yeah, that totally makes sense. And then when you heard about like the shielding side, like there was a demand for shielding. Did you just kind of get lucky that your technology had these shielding properties, or did you have to like make some adjustments to kind of get that property and that performance?
So we did get lucky to some degree because shielding is a lot about conductivity. What we had to do is we had to learn how to leverage those properties. So having a conductive fiber is just part of the deal because customers were asking us, hey, can you use an injection molding to make a shielded injection molded part? Can you use it as a fabric? Can you use it as wallpaper? And we said, yeah, I think so, but I need to work to crunch the numbers and look it up and talk to experts. So we really had to learn those things because in the end, our customers, for example, in the construction industry, they don't know what to do with the fiber, right? I can't sell them a bobbin. They can't do anything with the bobbin. They need something that a construction worker just glues onto the wall and is happy with it. So we have to come up with a design for them. Obviously, we have partners, right? We don't weave ourselves. We have weaving companies that work with us. We have non-woven manufacturers that work with us. But understanding what the need is and finding the right part that can process the material, that was a steep learning curve for us.
Wow. Well, we definitely discussed a wide variety of applications for these composite fibers today and how FibreCoat aims to make these accessible and affordable to everyone, which I find a very as a great goal to have. So kind of to wrap up our episode, what advice would you give the next generation of material scientists and material engineers who would like to get involved in the composite industry in some capacity?
So what I think, and I mean, I'm a composites engineer too, right? So that's why it's important to me. Don't try to do it alone because composites brings together the best of different worlds. In our case, fibers and metals, but there are many other ways to combining great things. So old technology to make something new. I think as a materials science engineer, you should keep your eyes open to the others, right? So if you work on metals, look what fibers can do. If you work on polymers, look what metals can do, and so on. So find the best of two worlds, because this is where composites basically work. And the good thing is you don't have to have everything, right? So for example, I know a lot about plastics. Alex, my co-founder, knows about is perfect with fibers. Richard is the expert on composites. And the combination makes it great, right? Not each one of us has all the knowledge. So I think this is the key takeaway from my experience. Keep an open mind and work with your peers.
Yeah, that's great. We actually heard like in a previous episode, like a similar piece of advice about just how there's a lot of breakthroughs that happen at the intersection of two fields. And so it's really cool that applies here and that you made an impact kind of with that interdisciplinary team and using knowledge from different industries to make an impact in composites. It's really cool.
Exactly. It all comes together. And if you then think bigger as a startup, you need the people who know sustainability, you need the people who know business. You need to, so basically you can only be, I think, successful if you know what your strengths are, you work in those, and then work with people who contemplate. So who it's the wrong English word, who combine with your strengths, basically. Yeah.
Yeah, complement your strengths. Absolutely.
Compliment. Thank you. Compliment.
Yeah, no problem. Yeah, awesome. Thank you so much for joining us today, Robert. It was a pleasure having you, and I learned a lot about composite fibers. I'm excited for the growth of your company.
Thank you. Thank you. It was a pleasure being with you too. And feel free to anybody who listens to this to reach out if you want to learn more about it.
Cool. How can they best reach out to you?
I think the easiest way is LinkedIn or through our website. So there's a mail address basically where you can reach me or my co-founders. Yeah.
We'll put that in the description.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.